Good evening, grade 8s. This is Mr. Casey. I'm decided that for our review of the circles that we're going to have a look at before our test on Monday, I decided that I'd do something a little different and create this video using Explain Everything to go through some of the things you should know for Monday's test. What I'm going to do is I'm going to go through some of the kind of sample questions that we may kind of get on Monday and that we've looked at in class already. So don't worry, there'll be nothing on the test on Monday that you haven't really seen or tackled a problem like it in class. So our agenda for this is going to be circle terminology, finding the circumference, finding the area, working backwards, and you know it, those juicy problems using graphs. What we're going to look at, I'm going to quickly, before we start, just go through what the test will look like. There will be a couple of true and false questions at the start, just to get you warmed up. We're going to have a couple of multiple choice questions, and then we're going to move on to some short answer questions where you can kind of just show your workings, how you find the actual solution. And then I'm going to have a couple of juicy problems where you'll have to solve the problem using the grasp model and explain your thinking with the paraphrase. So, as I said, it's the first time I'm trying this, so I hope you enjoy it. I'm going to go through it as slowly and as clearly as I can, but if you have any questions, please feel free to ask me in class or send me an email, and yeah, we'll get going. So, if we move to the first page here, we'll start with circle terminology. So, if you can think back to one of our first days talking about the circle, we came up with some terms. The first one I'm going to go through is if we drew a line like so. So you can see I've drawn a line from one edge of the circle to the other. But the key part of this line is that it doesn't pass through the center point, which is right here. So a line that doesn't go through the center point but goes from one side of the circle to the other is called a chord. Oops. Excuse my poor handwriting, but you get the gist. Okay, next thing you need to know is that a line that goes from anywhere along the edge or outer part of the circle to the center, like so, or like so, this is called the radius. You see it as a little r. And we have our next one, which is, we'll do this in a different color. If we have a line that goes the whole way from one side of the circle to the other, but goes through the center this time, like so, we call this our diameter, and we use a D to represent that. Don't forget, you'll notice some things when you look at these terminologies. You'll see if you draw it out that the diameter is going to be twice the radius. So already we've come up with a little formula that's going to be very useful when we're solving some questions. So we know our D equals twice times r. Also, at the start of this unit, we came to know this constant. A constant is a number that doesn't change, and we use it a lot in exploring circles. And this constant is called, I'll bring it up here, this constant is called pi. So we found out by using some exploration with some string that pi is roughly 3 times the actual diameter, or 3 times the diameter actually fits in the circumference, 3 times. So we have this constant pi, which is said to be the number 3.14. Because I'm more interested in how you actually apply your thinking to a question, if you can't think of what pi is, or if you can't think, oh, is it 3.14 or 3.41, I don't really mind. If you would like to use pi as 3 for your problem solving strategies, by all means do so. I just want to see that you can understand the problem and apply your knowledge. So there, the way the terminology. We're going to have a quick look at a couple more. They're the basic ones, and then we're going to move on to looking at what the circumference is. If you can remember, the circumference is the distance the whole way around a circle, like so. And the most important thing to remember about the circumference is that it's a measurement of distance. So our units are going to be usually going to be either centimeters or meters or kilometers if it's a big circle. Don't forget that when you're solving your long problems. And last but not least, I'm going to scribble a bit over my circle here, is if we are looking for the space inside this circle, we defined it in class as the area. So the area is the amount of space that something or someone takes up. So our area is written as A. So area is A and circumference is C. Unlike circumference, area is the measure of space, and our units are a little bit different. So when we're looking at area, like we saw in class, the area is going to be measured in either centimeters squared or meters squared, always making sure that you have the squared in place because it's measurement of space, not distance. Okay, so moving on, we have finding the circumference. So in order to find the circumference, we've got a couple of steps to follow. First step is going to be, we have our circle, we have to find out what the radius is of our circle. So if we have the radius here, we determine what the radius is, and we know that our circumference formula, we've learned from class that our circumference C is equal to 2 times radius times pi. But there's also another formula we can say for C, and that's involving the diameter. So we've learned already from our first slide that the diameter is twice times the radius. So if I draw it in a circle, our diameter would be here. So we can write another formula for the circumference, which would be circumference equals diameter times pi. And that's simply how you find the circumference. We did talk about in class about how you estimate the circumference. You might be able to estimate the circumference if you didn't know pi, for example, or you couldn't remember any of your math formulas. You could find your circumference by breaking it into simpler problems, using a piece of string to go around the outside of your circle and then measuring it using a meter stick, or rolling it. So finding out maybe the coin, put your finger where it starts and roll it along the page, see where it ends, and measure the distance there. Or even if we talked about the hockey puck in class, where you know the distance, the width of your pinky finger is roughly 1 centimeter, and you could move your pinky finger the whole way around the circle and find how many pinky fingers and hence how much the circumference is. So there's always different ways of finding the circumference or estimating it, but the accurate way is by using the formula. Remember our units, it's distance, so we're going to go centimeters or meters, or maybe smaller again with millimeters. Next one is finding the area. So again, we need to find some things before we actually find the area itself, starting with, again, the radius. So drawing our radius. If we find the radius, we can simply sub it into this formula that we derived in class. I won't be asking you in the test to derive the formula. It was a little tricky, but we did a classroom activity where I think most people understood. But as long as you understand the formula and how you might estimate the area, you'll be okay. So area is going to be equal to pi r squared. Okay, so pi again is our number 3, is our constant, r is our radius, and a is our area. And remember our units this time are going to be centimeters squared or meters squared. Always remember that area is the space that's going to be inside that circle. So all this space in here is going to be what the area is. You can also find the area if you're not given the radius. You might in a question be given the following. You might be told that the diameter. You might think, well, diameter isn't in my formula here, but we do know that diameter is twice the radius. So if we're given the diameter, split it in half. So we could say d equals 2 times r. So r will be equal to d divided by 2. So if we split our diameter in half, we would find our radius. If you wanted to estimate the area, again, we talked about it in class a small bit. For example, if we wanted to use shapes that we knew already or apply our prior knowledge, we would have to ask ourselves, what shape can we turn it into if we didn't know pi? Straight away looking at a circle, you could say, well, kind of looks like a square. You could draw a square around the outside. I'll just draw one here. You could draw a square around the outside, and that will give you a rough estimate of what the area is going to be by multiplying the length times the width, which for a square is going to be the same. So you give you a rough idea, and if you want it to be even more accurate, and if you could think back and think, well, wait a second, I know how to find the area of a triangle. It's a lot easier. You don't need pi. You could also slice off these corners. And again, once you subtract those corners from your square area, you could find out a rough estimate for your circle inside. Another way is also using grid paper, or using, like we did with the Bigfoot activity, a smaller disc or a smaller object, and see how many of them can actually fit inside. And by that, adding them up, you can find the area. This part is working backwards, and it's a little part I know a lot of people found a little bit tricky. So we're going to just show you and kind of review what we do by using a question. So we're going to start. Mike's pool is circular. If the circumference is 25 meters, what is the area? So we have to think, well, what are we given and what are we asked for? So we're giving the circumference. So I'm going to underline the circumference here. We're given the circumference and we're asked to find the area. So straight away I would think, okay, we're mentioning circumference and area. I will write down both formulas. Circumference is equal to pi times the diameter. Alright, and I also know that circumference is equal to pi times 2r, because diameter is equal to 2 times r. And now for the area, I would say, let's see, I know my formula, area equals pi r squared. So let's see what we need. We're given the circumference. So let's write it down. Let's fill it in what we know for our circumference formula. C equals pi 2r. If C is going to be 25 meters, we can say 25 equals pi, we know, is 3. We have our 2 and our r. So we'll know that now circumference is equal to pi times 2r. 25 equals 3 times 2 is 6 times r. A lot of people were getting a little bit confused at what you do here in order to get the r on its own. So to get the r on its own, we would divide both sides by what's in front of the r, because we want to get rid of this number here. So we would divide both sides by 6. And if we estimate what the answer is going to be, these cancel out. 25 divided by 6 is roughly 4. It's just a little bit over 4. But for this question, for the sake of simplicity, we'll just say r is equal to 4. And we look at our units and we see it's going to be 4 meters. So now we found out what the radius is using our circumference formula and working backwards. So let's see, we want to find the area. We now know our area formula, A equals pi r squared, and we just plug it in. Area equals 3 times r, we know is 4, and it's squared. This you have to be careful with. The 4 squared, the r is squared, and using our bed mass, I'll write it down. We always complete the exponent first. So we would do the 4 squared first before we multiply it by 3 or by pi. And we would see that area would be equal to 3 times 4 squared. 4 times 4 is 16. And we'd find out that 3 times 16 is 48. So 48, we look at our units, and it's going to be meters squared. So always make sure you put your units in so we know we're talking about distance for radius, diameter, and circumference, and area or meters squared for our area. And that's a pretty big pool, 48 meters squared. I wish that was mine. All right, next one. We're going to do another problem here. It's working backwards, a little bit trickier, but we're going to go through it slowly. So we'll look, Mr. Casey's fried egg has a total diameter of 8 centimeters. What is the area of just the egg white? So we have a few things here, and we have to figure out what are we asked to get again. So what are we given? We're given the actual diameter of the total egg, and that's 8 centimeters. What we're looking for is the area of just the egg white. So that's an important part, just the egg white. So if I want to find just the egg white, I will just shade in. It's going to be all of this area in here. So how you might do it, you might ask. Well, we got to work backwards somehow in order to find that area. So if we look at our diagram, we can see that I have a line across the middle drawn through the center. And we know straight away a line through the middle drawn through the center is going to be our diameter. These little marks in here, you can see in each section of the diameter show that the lengths are equal the whole way across. So if the lengths are equal the whole way across, so this length and this length, this length and this length, we know a total diameter is 8 centimeters. Total diameter equals 8 centimeters. Then we can fill in our diagram that this is going to be 2 centimeters. Oops. And this is going to be 2 centimeters. And so is this. And so is this. And what importance is that, you might ask? Well, you can see from looking at the diagram now that we have found some radius. We know that now the radius of the large circle is going to be 4 centimeters. I'll just draw that in. 4 centimeters. And the radius of our little circle is going to be 2 centimeters. So we now know that the radius of, I'm going to put SC for small circle, is 2 centimeters. And the radius of our large circle, or LC, is 4 centimeters. So now we think what we're asked. We're asked the area of just the egg white. I'm going to write this down. So we figure out the area of white is going to be equal to the total area of the whole egg minus the area of just the egg, or the yolk, the yellow part in the center. So I'm going to write that down. The area of the white is equal to total area minus the area of the yolk, or the yellow part. As you can see, I'm not going straight into the math. I'm writing down my thinking every step of the way. So even just writing down area of the white equals total area minus the area of yolk, you've explained to me that you know how to solve the problem. So if you go ahead and do the math and somehow mess up the math or get something wrong, I still know what you're trying to do, and that will get you most of the marks, because it's one thing getting the answer, it's another knowing and explaining how you actually come about that answer. So we would apply our formula. I'm not going to finish it off, I'm just going to show what we do. So the area of the white is going to be pi r squared. So the pi r squared for the white is going to be 3 times radius of the white is going to be 4 centimeters squared. And total area, that's the total area, minus the egg yolk, which is going to be pi, which is 3, and our radius is 2 squared. So that equals to 3 times 16, which is 48, minus 3 times 4, which is 12. So our answer is 36. What am I missing? Centimeters squared, because of area. Do not forget the units. Alright, hope you follow that one. That's probably most difficult it will probably get. So we move on to our final slide, and it's solving juicy problems using grasp. So I would like you to try this one as a practice question in class. I'm going to start it off by defining what the given and what the required are. And if you can remember back to our Einstein quote, if he was given an hour to solve a problem, he would spend 50 minutes thinking about the problem and 10 minutes actually solving the problem. So I want you to take that philosophy when you're solving these hard or juicier problems. If you're given a problem, you have to determine what you're given, and more importantly, what's actually being asked or what's required in the question. So that's why we use our GRASP problem-solving model. So I'll write it down, GRASP. And for those who can't remember, it's given, what's required, analysis, solution, and paraphrase. So for this question, let's have a look. We're told the area of the square is 36 centimeters squared. What is the area of the red shaded region? Apologies for this little 2 here. It should be a squared 2, so it should be up a little higher. So let's see what we're given. So I'll write the G, given. We're given that the area of the square is 36 centimeters squared. So area of square is 36 centimeters squared. Okay, that's about it. We can see from the diagram, we are given a diagram, and it shows us a lot of information. It shows us that we've got 3 curved or parts of a circle here, 1, 2, and 3. And we've got our red shaded area. We also are shown these symbols, which again mean that these lines, this line is equal to this line, is equal to this line, and this one, and this one. They're all the same. So keep that in mind when you're solving a problem. Always look at the diagram, what you're given. Next stage, we're going to look at our required. And this is where I'm going to finish and let you finish off the rest. So we're looking what's required. We're asked to find the area of the red shaded region. A lot of people, they think, well, if we're given curves and we know curves, we have to think about circumference somewhat. Think about what you're asked. If you're not asked about circumference, don't use it. So we're asked for area. So let's write down our formula right away. And required area equals pi r squared, just so we don't forget and we have it written down. And now let's think of what is required. We know what the red shaded region area is required, but what do we need in order to find that? So we might find, and let's do step 1. So we know the red shaded area, but what else? This is where I don't want you to stop. I want you to think what else is required. So in order to find the area of somewhere, we need a radius. So we need to find the radius. And the radius of what, you can see? Well, we're looking for the radius of a circle that's split up. So we're looking for the radius of a circle. Now, hopefully by this stage you can see where the radius might be. I'm circling it right now. So once you've found the radius, you got to think, well, what's required? I need to find out the area of these 3 sections. So I'll highlight them here. The area of 1, the area of 2, and the area of 3. So what we're going to write down, we're also required area of the 3 circle sections. And hopefully you can see from this stage and from our explanation that now we know what's required. The red shaded area. We need to know the radius of the circle first in order to find the area of the 3 circle sections. If we have the area of the 3 circle sections and we're given the area of the square, how can we find the area of the red shaded region? Oops. This is where I would like you to figure out the analysis and write your paraphrase as best you can. So that's it for the review, grade 8. I would like you to please do some practice questions. All the homework questions that I posted in D2L are really good practice questions for what will come up in the test. I would like you to come to me tomorrow and Friday with any problems that you can think of. I'll go through the structure of the exam again tomorrow while you're finishing off your culminating task and recording your videos. But from Mr. Casey, I'm going to sign out and say a huge thank you. See you tomorrow.